Hello and welcome back to another session of Flutter Original. And this week I am pretty excited for an advanced topic that usually we don't cover that much of those kind of stuff in this show. But this week we're going to talk about something that is not quite common, let's say, or well, maybe not quite normal to do in a daily work. So I have an expert on that topic at least today with me, Jochum. How are you, Jochum?
Doing great. Thank you for having me.
All right, very good. So, what kind of topic you're expert that I'm talking about?
Oh, I'm not sure if I'm an expert per se, but I'm really into shaders, and then especially shaders in Flutter, of course.
Okay, very
And
nice.
yeah, that's why I'm here.
Jochum, I think I was playing. I was just like checking Twitter a couple of times in the last couple of weeks, and I was all the time seeing your tweets about shaders, and I was wondering, like, okay, I think we should talk about that. And you're doing a lot of cool stuff with shaders, and many of us
Yeah.
don't even know what shader is. First of all, before we start talking about shader, can you introduce yourself a bit? Let us know who you are and why you are interested in shaders.
Of course. My name is Jochum van der Ploeg, also known as Wolfenrain on Twitter, GitHub, or pretty much everywhere on the internet. And I like to build games. I maintain the Flame game engine as well. I'm one of the maintainers at least. And I like to specialize myself in the obscure rendering things, like making, in that sense, art with Flutter in any way possible, be that through games, widgets, or in this case, shaders. And that's also why I'm quite knowledgeable about shaders, I guess. That's where it all came from. Is there
Okay.
anything you want
Sounds
me to
good.
add?
Sounds good, Joachim. Um, can you explain very simple to me what shader is or shaders are?
In the simplest way that I could say it is that a shader is like a processing functionality on the GPU. So, and normally, like if we write widgets, we can in Flutter we can have a container. We write our code, and we can have some logic to update the state. That always happens on the CPU, and based on the state, colors can change. We can do anything with it. But everything that we see on the screen happens through the GPU. It is rendered by the GPU to visualize it to our screens. And shaders are basically programming clauses and files for the GPU. So you can just say, hey, this should be the color red. And instead of saying in Dart, you say it's the color red, you can just say in shader, hey, it should be this color red. Or based on some logic, you can even have a whole animation running on the GPU. So you don't have to calculate anything on the CPU because they are quite bad at that. You can do that on the GPU for every pixel on your screen. So in the simplest form, that is what a shader is. And there are different types of shaders as well. And the one that we will be touching on the most are fragment shaders. That is what Flutter currently has support for in Flutter 3.0. But there are a lot of different shaders, and I'm probably not the expert for that. But on the fragment shader front, yeah, that's what I'm quite knowledgeable. And a fragment shader is the shader that basically runs for every fragment in your image or in your screen or whatever it is. And a fragment just basically means for every pixel, we will have a piece of code that will run. So for every pixel, we will determine which color that pixel will be. And because it runs on the GPU, it will be blazingly fast, and we can run through thousands of pixels in a fraction of a second without people even noticing that our code has executed 1,000 or 1,000,000 times.
Okay. Sounds interesting. So you said that Flutter is using some kind of special shader. Can you also elaborate on that a bit? Because I think most of my or audiences of this show are Flutter developers, so they like to know, like,
Yeah.
um what is it? Like how shader is impacting their daily work?
Yeah, so in the case of Flutter, since Flutter 3.0, they have added support for SPIR-V shaders. Probably pronouncing that wrong, but it's a shader language from that's used by the Skya engine, the rendering engine behind Flutter, and basically it allows you to have a widget that uses a shader, whatever shader that is, to just render something visually on your screen. So that could be an animation. We all know writing animations in Flutter, like making it beautiful, requires a custom paint, it requires to do a lot of things, but then you can't use a widget easily inside of it. So a shader allows us to write any visualization in the SPIR-V language or in GLSL, that's another shader language, and then we can just compile it inside our code natively, and it just runs on all platforms except web. And yeah, you can manipulate images, you can do anything you want except change how your whole app looks. So we can't access the what currently on the screen, but we can add extra things on the screen using shaders, if that makes sense.
Yeah, yeah, sure. Okay, sounds interesting. But how did you like find the shader interesting to you? Like, where did you find the first motivation?
The first motivation, I found this. I found that someone was working on this from the Flutter team like almost 6-7 months ago, and because I do a lot of game development, both on Flame, but I have also done Godot. I've worked with different game engines as well, and shaders are really a core part of games because it allows you to change things on the go in a game without having without an impact on the CPU, without having to make your game slower, because everything that you do with shaders happens on the GPU. So, for instance, if you have like a little dinosaur walking across the screen, and you want that dinosaur to have like a nice black outline, and depending on how far it walked, the outline changes color. That's something you would do with a shader, because a shader, as I said, per pixel does something. So if you have an image, it can go through each pixel of the image and determine, hey, should there be an outline here or not? And that allows you to just change your game on the fly. Flutter did not support that at the time, which made me a bit sad. So I tried to look up if anyone was working on something like that. And then I found this SPIR-V repository somewhere in the Flutter package, and I found some specifications about it, that they were working on supporting it. And that's kind of where it started for me. I basically just started to test out every time there was a new commit, see what can we do now? Can we now use it, or is it now more stable? What new operations of shaders are supported, and that kind of stuff. And yeah, as I mentioned, it was like 6-7 months ago when I started looking into it, and because I kept up with the whole development, I kind of built up the whole knowledge base that I have now, which allowed me to, well, basically do also this talk, but also make my own tool called Umbra that basically automates certain aspects of it, because
Hmm.
it's not like a first person support in Flutter. It's not there yet, but we can already use it in production, and well, I think it's quite awesome.
Okay, so here's the point. You mentioned about Umbra. So you want to explain a bit more about it? Like, what is this project?
Yeah, Umbra is a tool that I created out of a necessity, because right now, if you want to use shaders in Flutter, you can write a shader in the GLSL language, but then you have to manually compile it to a binary. You have to add that binary as an asset to your Flutter app, and then you can finally use it in your code, but it's not strongly
Mhm.
typed. So shaders can have input, and based on the input, it can do something else. There's like arguments on a function. But those inputs have to be like floats. They have to be a list of doubles that you just pass along. And because it's not strongly typed, those inputs in your GSL code could be like a color. So those are 4 values, but they are just a single property inside of your code. But when you have to use it in Flutter, it's basically just like you have to pass an array of 4 items. And if you have multiple inputs, it becomes quite hard to keep track of, oh, which value is which one and why do I add it here? It's not strongly typed. And you have to do a lot of manual setup. You have to compile it manually. You have to install a third-party software for that. And it's it's not it's not a good developer experience. And that's kind of why I created Umbra, to take away all of those necessary steps, take away that not strongly typed API from Flutter, and build a sort of abstraction around it that allows you to do exactly the same things, but without having to know how it works.
Oh, that sounds very cool. But is it like a package or library, or how can we get access to that? If someone wants to use it.
Yeah, so Umbra comes in 3 packages. We have the core package called Umbra. As a normal user, you would never have to use it at all. It just has some of the core functionality that the 2 other packages need, which is a CLI. So I have created a command line interface that basically does all the generation for you, all the compilation for you. So you only have to run one command, and it will generate everything you need. It will generate a Dart file for you that you can directly use inside of your application based on your own shader. And then I also have like Umbra Flutter, which is basically like an integration package that you have to add to your own app to use Umbra generated code inside of your application. So yeah, it's
Okay.
basically a command line interface and a simple package
Okay.
that you add to your own to make use of it.
And that is leading us to per programming session. Now we can jump into some code and writing some shader codes and see what exactly it means when you're talking about this stuff. Are you ready?
As ready as I'll ever be.
Okay, so let's get started. So can you then open up your editor and tell us, like, give us some quick intro, like to maybe Umbra and as well as some shader stuff that you were mentioning. Like if I want to use it in Flutter directly, how can I do that? How can I use Umbra and stuff like that? Let's do some pair programming here together.
So I created a really simple example project. It's completely bare bone. I stripped it down to whatever we need for this right now. So I'll have a quick rundown on what it currently has. It's basically, we have an image, which probably an image everyone already knows. It's the cutest dash ever. And I've set up a simple stateless widget that right now just shows 2 times the same image. It shows the image top and the bottom. And the bottom one is the one that we will be changing using shaders. And this is where Umbra obviously comes in. Like I already added the Umbra Flutter version, Umbra Flutter package to the dependencies. This is the only step that people have to do inside of their application. And then locally on their machine, they can then install the Umbra CLI using the Dart pub global activate and then Umbra CLI, which will install the latest version. No, I already had the latest version because obviously I've been using it. And now the Umbra CLI is installed. So I think the first step would probably be that we should create a new shader. And you can obviously create your own shaders manually, but Umbra does come with a create command, which currently holds 2 templates. Let me make this a bit bigger. So we have the simple template and a translating shader. Well, we'll just use the simple one for now because we will be completely changing it. I have no good name for it, so we'll just call it example, which will create an Umbra shader for us. I forgot to put it in the right directory. That's my mistake. So it has generated an example GLSL file for us, which is the language that the shaders in Flutter use. And as mentioned before, like Flutter uses SPIR-V shaders, but you can also write them in GLSL and then compile them to SPIR-V binaries, which Flutter is able to interpret. So this language is much easier to work with. Let me move this into the shader directory. And this shader basically what this does, it's a fragment shader. It has two inputs and it has an output value. And the input values that we receive, these are generated by Umbra. So what we see here is not the full shader. We can touch on that in a second. I wanted to explain a little bit what this code does. So this is the UV mapping, which is basically a value between a vector 2 with a value between 0 and 1, because everything in shaders is normalized. So if you have an image that's like 1000 pixels by 1000 pixels, you won't be working with like a position 500 by 500. That would be 0.5 by 0.5. Everything inside of shaders is normalized. So that's what the UV value is. This is the current position normalized based on how big our image or rendering will be. And then we have the fragment coordinate, which is the coordinate on the image. So this is the real pixel coordinate. So if the image was 1000 by thousands and we were halfway through the image, then it would be 500 by 500. So these two values are what you often use in shaders. Most often you use this one, but there are valid use cases on why you would need the whole full not normalized position as well. So that's also why I am exposing that. And what you return here is basically a color with the alpha channel. So this is red, this is green, this is blue, and this is the alpha channel. And each fragment call that happens, so this happens for every pixel inside of an image or inside of a rectangle that we are rendering. So we have to return a color for each pixel.
Right.
So far, so good.
Yeah.
As I mentioned,
well, it's so far so good, but we just need to see, like, we see it in action. Let's put it that way.
Yeah, exactly.
But let's continue. So far so good.
Like, yeah, what I just mentioned, this is basically this is a real bare bone shader. What this currently does, it generates based on the position a red to green gradient. That's what this will do, because based as I've mentioned, the UV is 0 to 1. So basically this will be slowly going to red and this will be slowly going to green on the different axes of your rectangle. So if we use Umbra to generate something from it, so let's try to generate the like a widget. So Umbra supports multiple targets, generation targets. A dart shader, which is the default. This would just generate a shader that you can use in anything that's related to Flutter. So you can use it in a widget, you can use it in Flame, you can use it in a custom paint. This is the lowest level thing that you can generate. But what we will be generating is the Flutter widget, which will abstract all the logic for us, so we can just immediately throw it inside of our widget tree.
I see.
So let's example, and then the target will be
just
Flutter
out of
widget.
curiosity here.
Yeah.
Why do we need to generate that in pure Dart? Like, what is the use case?
The use case in this case is that if for these two, that shaders are not usable in Flutter directly. You have to write some logic around it to interact with it. And we can have a look at the Dart shader for that in a second. But what this allows, it will generate the SPIR-V binary for us and add it to the Dart file and generate a class for us that we can work with inside of our code. And that allows you to just, you don't have to add any assets or anything. You just have a single file, this one, and based on it, we can generate all the code that we need to have this file, this shader working in Flutter. So if I run this, oh, what did I do? Oh, yeah, it does not, Umbra does not create widgets for directories for you right now. So I wanted to generate it in lib widgets, which did not exist yet, so I had to create it manually. So it's generating it now. And now inside of widget, we have an example.dart. And inside of the example.dart, we have a generated code, which extends an Umbra widget, which has all the logic we need. Some default parameters that normally you would want to use. And because we do not have any inputs right now, which are called uniforms in shader language. These are empty. We will be adding them in a second. And this is like this part is basically what the core of Umbra is. This is what you would normally do inside of Flutter if you were not using Umbra. If you wanted to use the fragment shaders manually, you have to compile it using the fragment program, which is something that Flutter exposes. And then you have to provide the SPIR-V binary. Normally, this would then come from an asset file. In our case, it's encoded inside of the file because normally you would already have it, and this would compact it a little bit, making the size of your code the size of your application a lot smaller.
Can you remind me again? What was this SPIR-V?
Right? SPIR-V is basically like the backend language that Skya uses to interpret the shader. So it's a standard for compile for shaders to be uploaded to the GPU. So if you're running on macOS, the SPIR-V will know, oh, I have to use the macOS backend for GPU, which is Metal. If it's running on Android, it will know, oh, I can use OpenGL. So it will be able to interpret whatever you wrote in a standardized way and upload it to the different platforms processor.
Okay, makes sense.
SPIR-V is, by the way, a really complex thing in of its own, and I won't say I'm an expert on it, but it's not the best solution that Flutter could have chosen for this, because it does come with a lot of limitations. But for the use cases that most Flutter developers will have, it's perfectly fine. But for game development, it's sadly not the best option.
Okay.
I think we should probably have a look at how this looks in action.
Yeah.
So I'll just replace this raw image. Let me first, yeah.
Before you move on to how it looks like in action, I noticed that in the example file you created, you extended Umbra widget,
Oh, yeah,
right? Class.
Exactly.
So can we take a look at that widget? So see how is the implementation over there? Like, I really like to know, like, what did you abstract away?
Yeah. So the Umbra widget is a stateless widget that, as you just mentioned, abstracts away a lot of logic. As you can see, it has a few options because those few options are related to its build method. And if you go a little bit down, its build method, basically what it does, it requires the fragment program, which the fragment program is the backbone of shaders in Flutter. Once you have the fragment program compiled, which is what we were doing here, once it's compiled, based on that fragment program, we can create the shaders that Flutter needs. So this compiles the SPIR-V binary, it reads it, and knows what to do with it. And then later on in let's see, where is it? Here in the shader mask, we can use the program.shader, which will return a shader instance from our shader. And it requires a few inputs based on whatever inputs your shader has. And yeah, this is the whole file. It's really simple. But what I've done here is a future builder to get the fragment program. If the compilation fails, either the arrow builder will be called because people want to maybe show something different. Oh shit, something went wrong. Let's show a nice widget. Or it will just return an arrow widget like Flutter normally does. And if it doesn't have any data yet, it will check, hey, did the user supply a compiling builder? So basically like the image loader builder. This will call whenever it's still compiling, because compiling the fragment program can take a few seconds. And obviously you want to show an indicator that that's happening for your users. And if none is provided, either we return a child, like if the child was given, otherwise we'll just return basically nothing, a sized box to just keep the widget at least alive in the tree. And then if everything went well and it's done compiling, then we have a program, a fragment program. And in the fragment program, or at the end of the build, we will have a layout builder, which returns a shader mask. Shader mask is something that is exposed by Flutter already that you can use to because Flutter already has like gradient shaders and a few others. And this allows us to overlay a shader on top of a child. So that's what the shader callback does. It gets the bounds that we require, and we pass the float uniforms and the sampler uniforms. We'll touch on that in a second, I think. And we add the bounds. So basically, we require the size of the current rectangle to calculate the UV value that I mentioned before. So Umbra already removes all that logic for you, that you don't have to pass your own bounds and that kind of stuff based on the shader callback. And then finally, as we add a child for the shader mask, that's basically a transparent container with a certain width and height. And this is required because the shader mask expects that its child will define the bounds. Not that the parent will define the bounds, but that the child will define the bounds. Because based on that, it will generate this bounds value. So we have a container that is transparent, because if it's not transparent, based on your blend mode, it could bleed through. And we have the width and the height for the bounds. And then if the person that is using this shader or this widget has passed a child, we will also render that child under the shader mask. So that allows you to overlay certain shaders on top of any widget that you require. I guess, yeah, that's about
Sounds
it.
good. Now time to see it in action.
Yes. Well, I already started it up, so this is the current implementation. It's just rendering the same image twice, and we'll just replace this with our example. And right now, so it should be a constant. So we are not passing anything, but if we now check back at the debug console and then the tool, this is basically what it generated. And this would be a good moment to explain how this probably works, I think. So this is our fragment and the shader, and it has generated this beautiful gradient. And basically this gradient is generated because, as I mentioned, it returns a color, and based on the position, so here it's 0, 0. So the UV point X is 0, the UV point I is 0, so the color will be black, because then it will be 0, 0, 0, 1. So RGBA, that returns a black color. And here on this side, it's completely red, because that's the x-axis. So this one would be 1, this one would be 0, and then the blue will also be 0, so it will turn red. And the same for on the y-axis. Here it is green, because the UV point X is 0, the UV point I is 1, so it will have a green color. And then at the bottom right we have yellow, because if you have red and green together, you get yellow. So this is our shader that was just generated. And I think it might be interesting to see some inputs to see if we can like change some things related to it. Let me quickly open my own example here so I don't completely get off the road. So uniforms are basically properties that you write at the top of your shader file. Like, for instance, if you wanted an input value of like a float to determine, bijvoorbeeld, the blue channel, you would just write uniform float blue channel, and then we can put that here. So now we have an extra input to change our gradient. So this will still stay the same, but the blue channel will change depending on which value we pass. So if we regenerate our shader right now, we added one single uniform. And if we regenerate it, it will ask, hey, do you want to override it? Yes, we do. And now you see that we already have an error in our code. And that is because we have added a uniform, and uniforms are required right now in Umbra. So it has added this blue channel property or argument to the constructor that is required. And it will pass it to a private field, and then in the float uniforms, it will return this value. So this will always return all the properties that you define, all the uniforms, in the correct order that your shader expects them in. So if we had something like this, a red channel, and we would have had a red channel here, this would work, but this would not work because it does not know the order. The order of the floats that we have in this array are also the inputs for each of these uniforms. So it's always in order. And we can see that when we add another uniform in a second. But let's first see what has this visually done for us. So let me add a blue channel. And as I've mentioned, everything in shaders is normalized, so the colors are also normalized. So in this case, probably if we do 0.5, that would be like in between not blue and blue. So like 122-ish when you're talking about RGB values. And if we now check our code again, it didn't change because it's a stateless widget. So let me reload it. Now all of a sudden we have a whole different gradient that, in my opinion, even looks better. And if we change this value to like, let's put it to on 1, or let's put it to like 0.2. So we can now easily change our shader without having to recompile our code or anything, because the shader didn't change, only our input values changed. So this is the basic way of adding input to your shader. But we have more types than only floats. We also have vectors, vec2 and vec3 and vec4. Let me think of a good example why we should use a vec2. Let's say we want to control, instead of using UV, we want this to be static. So we'll just say red and green channel. And then instead of having UV here, we'll just red and green channel.x and red and green channel.y. And then we just regenerate. And I'll just add one parameter so it won't ask me if I want to override constantly. Now it has regenerated our example file. And as you can see, it has added a vector2, so it's strongly typed. That's the important part. Red and green channel argument. And then here in the float uniforms, it will unpack that vector2 in the right order for the shader to interpret it. So as mentioned before, if we now do this, the red and green channel value, this value, will be the value of the blue channel. And this vector will have the value of y as its x value, and then the blue channel as its y value. So because it's not strongly typed by default, Umbra has a whole abstraction around it that generates that strongly typed API for you and makes sure that everything is in the right order that your shader expects it to be. So let's add this vector2 to this. So if we do vector2, I'll just think of some values, and 0.6. Why is this not? Oh, yeah, it no longer can be constant because this is not a constant value. And if we now look at our code, it's completely green. Didn't expect that, but hey, it did change at least. Don't know why it's green though. That's probably because of... Oh, that makes sense, because now it's no longer based on the UV value. So it's now mixing whatever we have statically here with the blue channel. So if I put this to 0, it would be dark green. And if you put this to, yeah. So now we basically have two properties to determine a single color, which is not really useful. But that's how uniforms work in shaders.
Okay, Jochum, I think I get what you're talking about, so that's interesting. But I have one question here. I mean, now we see some examples in action. When is the time to start playing with shaders? Like as a developer, like when do you want to even tap into that?
Oh, that's a good question, honestly. I think once you really need to do something that's really CPU intensive, animation wise, that would be a really good moment to see if you can rewrite that animation as a shader. because if it's on the shader, if it's written as a shader, it will happen on the GPU. It won't block anything on the CPU. It won't block your application running or whatever. It will just run on the GPU, which allows you to have really smooth shaders, really smooth animation. For instance, a loading indicator that has all these kinds of explosions happening or something like that. That's a really good use case for shaders. The reason why that's a good use case for shaders is mostly because right now Flutter does not allow you to act on the current canvas. So you can't, everything that's rendered already before your shader starts, you can't access, which you normally can if you're talking about shaders in the rest of the world. But Flutter right now does not support that. And if it did support that, then you could have your whole application change however you want using shaders. Like if you want to have this old vibe of like an old TV screen, like with those scan lines and that kind of stuff, you could use a shader for that. But Flutter does not support that yet. So right now, shaders, using a shader in your Flutter application is especially useful for really massive animations that do a lot of things, and you want that to offload to the GPU.
That makes sense. Okay, let's move on. So you have another example that you wanted to show us right now. You mentioned. Move on.
Yeah. Okay, so as I mentioned, there is an image here, and obviously this image wasn't there just to be cute. Well, it is cute. We're going to do something with it. So I'll rewrite this code a little bit. We'll just remove all the uniforms right now, and we'll add a new uniform. It's still going to be a float. I'll call it the pixel size, because what we are going to do, we're going to pixelate this image on the GPU. So we will see a pixelated variant of this image without having to add any new assets or whatever. We'll just use the single shader for that. So we'll have a pixel size, which will determine the pixel size of the new image. And what we also need is access to this image. So we will write a new uniform. And to access images, you'll have something that's called a sampler. In this case, a sampler 2D. Sampler 2D. Now call it image. And the sampler is basically a big list of values, of pixel values, that you can use to just check, hey, what color does this image, this input value have? So it's a really massive list of just pixel colors like you would normally have in like a two-dimensional array. And we'll just add a little image description, image to pixelate. So we'll just, let's remove this. So what we want to do is to have a method that basically is able to calculate the new pixel value. I should probably turn off, well, it's okay. That will determine the new pixel value of your image. So I'll create a simple function, because I like to keep my own fragment methods as small as possible, and just have a method that is more determined of what it does. So we'll just say pixelate. It will still get a position. So I'll call this a position factor. This is basically the same as the UV, but this is more descriptive than UV. And we'll have the resolution of the image. And that's something we can touch on in a second. So we will call this pixelate method. As you can see, it returns a FAC4 because this will return our color. So I'll just say pixelate. We'll pass the position, which is UV. And now we come a little bit of magic. There are two values, or there's one value called resolution inside of Umbra that we don't see anywhere in the code. And Umbra does inject certain values. Currently, it injects the resolution value for you. So as I mentioned before, in the Umbra widget, we have this get float uniforms, and we add two more values to it: the width and the height. And that's basically the resolution. We add this so we can do a bit of extra calculation to determine how big a certain image or a certain rectangle is. And we calculate the UV based on it as well. And in this case, we want to calculate the new resolution of our image. So we have this current resolution, for instance, it's 500 by 500, and we want to downscale it to a certain pixel size. So you can just say resolution.xi, which will return a vec2 as well, but a clone of it, so we won't be changing the current resolution, and we'll divide it by the pixel size. So right now we will get the current position, the UV position as I've mentioned before, and the new resolution that it should be. And based on those two values, we could return the pixel color that it should have. So this will be a bit of fun math that not everyone is happy about, I guess, but I'll just write it. So what we want to do first is we want to scale our current position, exactly as that. We want to scale our current position based on the resolution. So what you normally do is then you scale it and then divide it, and this will return a new position inside of your new resolution. So this was generated based on the old resolution. This is generated, and this position will now be generated on the new resolution. Because of this, the value of this position can now be bigger than 0 or smaller than 0. So we want to basically make sure that it won't return a vector color that is too big or too small outside of our current image width. It's a bit hard to explain, but I hope the code makes a bit sense. So we'll just want the max value of the current position of the new position minus its halfway point, compared to the position I is minus halfway point. So if these values, if either of these returns bigger than 0.5, you can assume that whatever this position value is, it's outside of this image range. If that makes sense. This is not something that I've thought of myself, but it's quite common if you look into shader code from other people, that if they do something with resolution, this is how you determine if it's outside of the current image or whatever resolution you're working with. And then lastly, the only thing we have to do is return the current pixel value of our image based on this position. So in this case, we can use the texture method, which is something that's commonly known in GLSL. And this method just returns the current vector value, the current color value on an image based on the position that you give. So in this case, we'll give the position image, and we'll have this image. So it will return the color of the image at that position, and we want to make sure that it's a copy of it. So we'll return RGBA because we need a vec4, and this should theoretically pixelate our image. So what we have now done is basically we have added a sampler to the image, and we are basically checking, hey, what is that color? And we are returning that color on a fragment, and we're doing a bit of math to make sure that we scale up or scale down our pixel resolution. So I'll just regenerate my example code right now. And as you mentioned, as you would have expected,
meanwhile,
yeah, sorry.
You have I have a question here. So that GLSL file, so we should always have one fragment function, right?
Yeah, there's always one fragment function per shader.
Mm-hmm. But technically, we can create like several GLSL file and and do different things, right?
Yeah.
Okay. Okay, let's move on.
Yeah, so you can have multiple shaders for different use cases. And each shader will have its own functionality in that sense. Okay, so we have now two different properties, the pixel size and the image. So I'll just have the pixel size. I'll say it should be a pixel size of 8. And we can pass our image. So this is where a little bit of the magic comes in again. If we look at our example widget, This is a image from the Dart UI, so it's not the image widget, it's a raw image that you normally can get from an asset or whatever. So at the top here, I got the assets, the image data, and I decoded it to a raw image, and then we have access to that. And then here we can pass it along, and then in the sampler uniforms, we can then return an image shader. So this was something you would have to do manually as well. And the image shader is then the sampler that our shader is able to interpret it. So you can also change the tile modes if you wanted to. That's something Umbra currently does not support. I'm still looking into how that would work and that kind of stuff. But this image shader is basically the shader that our shader is able to interpret it as the sample 2D. So it returns that here, and by default it has an identity that is just a matrix for a float 64 list, which is just required by the image shader. It does not do anything extra. But in theory, we could change this to something else to manipulate this image shader before it comes to our shader. So you can have like stacked up changed images and that kind of stuff. Is something that Flutter does not fully support yet. So that's also why Umbra is not yet using anything of that. That's why this is also static. But that's the generated code. That's the abstraction of Umbra. We only have to, as a user, we only have to pass the image, the raw image, and then we can just reload our code. And there we go. We have a pixelated version of our image. And if we would increase the pixel size, it becomes even more pixelated. On the fly, it happens on the GPU, does not stop your rendering or your code or whatever. It is not blocking any kind of UI thread. And you can do a lot of interesting stuff with it, as you can see.
Well, that's very cool. It's actually a good example right now, I see. So yeah,
Yeah.
very interesting, very interesting, and it gives me some idea of doing something interesting on the next Flutter Vikings application for for this summer.
Oh,
for in
that's
the in
awesome.
person event. So you might see some of these pixelated stuff on the app. So we'll see. But this is
Cool.
very interesting, Joachim. So I think this use case that you showed, it just makes more sense. Like, why do we need to tap into the shaders, and why do we need to do that? And I understand it
Mm-hmm.
that way much better. I hope that at like our audiences also understand that much better. So, and I have maybe one or two more questions, and then we can wrap it up. So you said that this is going to be pretty performant, right? So because it's running on GPU, and
Yeah.
then that's why it's pretty performant. And when you say that, so well, technically these days, many smartphones are like pretty good, like in terms of the hardware. So, but when we're talking about performance, are we talking about like low end, let's say, devices, or like what you're talking about, like the latest Android or iPhone, mobile device? So what kind, this is very subjective when we're talking about performance, right?
Yeah.
So what do you mean when you talk
So
about it?
yeah. So from my experience, from my testing, I found out that really old Android devices perform quite well, as in it does not stutter, it does not drop any frames at all. It just keeps walking. But it also really depends on how uh, expensive your shader is. So what we just did with this texture method, this is a really expensive operation. If you do this once or twice or maybe 5 times in one single shader, not a problem. But if you do it like 20 times or 30 times, depending on the hardware, it might be a lot more expensive, because it has to constantly look up the image data every time you call this method. So it will constantly have to
I
swap
see.
data on the GPU to even be able to look it up for you. So the performance also really depends on how well your shader is written. And that's obviously outside of the scope of Umbra. That's what people have to do themselves. But you can write really performant shaders if you want to by caching a lot of values. But then you also have a limited data size that your shader can be and the data that it can use on the GPU. So you can't cache a lot of values because then you have like a sort of Stack Overflow issue. So as you mentioned, this also really depends on what you consider performant. Like a really simple shader will perform amazingly on all devices, but a more complicated shader might perform much worse depending on how you've optimized it.
So taking this example into account, first of all, if you want to do it differently, how would you do that? Like, is that possible to do it not with shader, with like other way to do that?
I'm not sure if you can. This specific example, you can probably sort of redo in Dart yourself using a custom paint by just reading the pixels once, which is an expensive operation, but you only have to do it once. And then based on your resolution and your pixel size, you can do all of this math without the shader. I do have one other example that is something you really can't do with Flutter as far as I know. And if you want, I can start it up right now. Because I've based this code base on the examples that are inside of the Umbra repository. So this pixelation code is something I already written before. That's why I knew how it worked. But if we take a look at this, for instance, here on the right, this is something you probably can't do inside of Flutter. But yet this is running inside of Flutter because I wrote a shader for it. And this would be considered a more expensive shader because it's doing a lot of things over time. It's constantly updating. But this still performed quite well on an Android 5 device for me. That's from like 2016 or something. So shaders, if you write them well, can be really performant.
Do you have this
and
example?
Some things can be done with shaders and some things without. Yeah, sorry.
Do you have this example link somewhere that we can just take a look at that later?
Yeah, they are inside of the Umbra Flutter package on the Umbra repository. This is the example to showcase it.
Yeah. Okay.
It
Sounds
even has
good.
the shaders.
Okay. Sounds very good. All right. I think we should wrap up the session. It was actually very interesting. I was like looking at what you're doing, and I'm sure that we can go even further and then do like amazing things that you've done so far. You know, with the example that you showed me right now. But well, I think we should also take into account the time of the show. Well, I actually invite you to come back once more to Flutter Original, and then let's talk about more advanced and more complex and use cases like the one that you've right now showed us. It's actually the one that I was thinking about to do with the splash screen or like the onboarding screen of Flutter Vikings. So, and then you suddenly show this one. And I was just, these kind of things, they're very cool, especially if they are like performing very well, then why not doing that, right? So I want you to invite you to come back to this show once more and then maybe go through some different, complex and also useful examples that we may want to use it in our daily work. Also, I'm sure that you're working on Umbra, like, and adding a lot of features, making that better and better every day. So, I know that you're working on that. So please, then later when you have a major release or a lot of features, come back and tell us what you've done and how we can use your package. So that would be fantastic. And with that said, do you have anything to share as the last words? So anything that you want to share with us?
No, not at the moment. I would obviously invite everyone to check it out. That would probably be my last thing.
That's fantastic. So I will put all the links to the repo packages, Jochum Twitter account, and all the social media he has. So then you can have his profile, so contact him and talk to him, open an issue. I think he will be happy to see some issues for Umbra, and also ask him
Always.
features for Umbra for sure. And with that said, thank you very much. So I'll see you in the next episode, and I'll see you everyone in the next episode. Have a good day, night, wherever you are.